Alright, so let's write down a partial fractions decomposition, really just the first step in the decomposition for this rational function. Notice that we would like the first factor, but we've already got the denominator factor. There's nothing else that we can factor. Next, simplify if possible, and we can. The x squared and the x cubed will simplify. So this is 4 over x times x squared plus 3. Next, we need to break it up into the component parts. One for each of the denominator pieces. This one is as straightforward as it could be. It's just a constant above it. But remember that when we have a quadratic term in the denominator that's unfactorable, that I can't break apart any further, the numerator can't just be a constant. And the reason is essentially because our numerator over here, this is a cubic in the denominator. So the numerator might be anything up to a quadratic, might have an x squared. So that would be an ax squared plus bx plus c. In order to allow for any possible numerator that might have 3 variables, we're going to need to have 3 variables over here as well. And the way that we do that is to allow for a generic looking linear factor above it. So if this is a quadratic, if it's an x squared, we'll have a generic linear, just an x above it. If I had an x to the 4th down here, this would be bx cubed plus cx squared plus dx plus e, just as a constant. We always have to have this be 1 degree lower than whatever the denominator is. But that is the first step in our partial fractions decomposition.